Let's start our tutorials by the very first topic in our very first module, basic concept. In this video, we are going to talk about electrical safety. Safety first is the motto of every good engineer. In this unit, we'll discuss the electrical hazards and preventive actions to avoid accidents. Electrical shock. Wherever you see electrical hazard sign that looks like this, you have to be careful in your working and handling of electrical devices and appliances. Electrical shock is caused by the flow of current through your body. Current needs a closed path to flow. You can see in this diagram, the birds which are sitting on the high tension wire do not feel any electrical shock because the path is not closed. So there's no path for the flow of current through the body of the birds. But an electrical worker, because of the nature of his human body, he closes the path for the flow of current and he is connected to the ground. So he can experience an electrical shock. The severity of the electrical shock depends on the amount of voltage and the path that currents take through your body. Now, effects of electricity on the human body. You can see these are the current levels in milliamperes and the effects these current level cause on the human body. So 1 milliampere is like threshold of sensation. So you can feel some sensation in your body or on your hand if you're touching any energized circuit which has 1 milliampere of current flowing through it. Around 30 milliampere, it's possible that you might suffocate. You will stop breathing. Above 90 milliampere of current, it's dangerous. You can see this is red zone, and around 1000 milliampere, which is equal to 1 amp, it's very dangerous. Around 100 milliampere, your heart stops breathing, and at 300 milliampere, the breathing totally stops. 900 milliampere can cause severe burns on your body. So you have to be careful when you're working on an electrical circuit. So whenever you're working in an electrical circuit, you have to take certain safety precaution. You have to avoid contact with energized electrical circuit. You have to treat all electrical devices if they are live or energized, because you never know. Disconnect the power source before servicing or repairing electrical equipment. This is the only way you can be sure that system is not energized. So you better disconnect before you start working on your electrical systems. Use only tools and equipment with non-conducting handles when working on electrical devices. If it is safe to do so, work with only one hand, keeping the other hand at your side or in your pocket away from all conductive material. It restricts the flow of current through your heart. Equipment producing a tingle should be disconnected and reported promptly for repair. They should also be marked so other people don't use those faulty equipments. Do not rely on grounding to mask a defective circuit, nor attempt to correct a fault by insertion of another fuse or breaker, particularly one of larger capacity. So if the circuit is not functioning properly and the fuse is blowing or the breaker is tripping, do not replace the breaker with higher ratings because there's a fault in circuit. Till the fault is not removed, the circuit is not safe to work upon. Capacitors, you have to drain capacitors because capacitors are energy storing devices. So you have to drain capacitors before working near them and keep the short circuit on the terminal during the work to prevent electrical shock. Never touch another person's equipment or electrical control devices unless instructed to do so. You also have responsibility to protect others around you. Enclose all circuit contacts and conductors so that no one can accidentally come into contact with them. De-energize open experimental circuits and equipment which are left unattended. Do not wear loose clothing or ties near electrical equipment. Act like an engineer. Please do not make fun of these rules. If you already know this, and remember that if something bad occurs, you probably won't have second chances. So you have to be very careful, and you have to take all the safety precautions while you're working on an electrical circuit in your lab environment.